Hello, my name is Christian, and today we're going to talk about srcSlice. The first thing you need to do is get srcML, which you can do at our website, srcML.org. If you hit the Downloads tab, you can find srcML. If you hit the Tools tab, you can find srcSlice. For today's presentation, we're basically going to take this sample piece of code, run srcSlice on it, and then we're going to examine some of the slice profiles we got out of it. To start though, let's run srcSlice on a larger piece of code, about 3 million lines, and we're going to see if it can finish before we finish this demonstration. So pair review is what we're going to run it on, and we're going to redirect the output to p.txt. So we'll run that and see if it can finish. So to begin with our demonstration, first we need to take this code and put it into a srcML archive. So let's go to our srcML build, and then we can run it on srcSlice test.cpp. We'll redirect the output to here, and additionally we'll turn on the position information, which basically tells srcML to give us line numbers for identifiers so that srcSlice can use those to do some computation. So we'll run that, and then we'll get this archive here. To run srcSlice, we'll basically just we'll run it the normal way and then give it the file like that. Just hit enter, and we'll get the slice profile. So here each row corresponds to a slice profile, and from left to right we see the file name, and then the name of the function we found the slice variable in, the name of the slice variable itself, and then def, which is the first thing we'll be looking at here. So def is when a variable is declared or when its value is modified. And so here we see that I was declared on line 11, which is why def got the line number 11. Use corresponds to when a variable's value was read. So 1, 2, 5, and 7 are the first four. Let's look at those. On lines 1, 2, 5, and 7, you'll notice that there is no I. This is because srcSlice can do interprocedural computation, or computation over slice profiles. So it sees that I was used in both foo and fun, and so it records that I's value had some impact on foo and fun in those positions. Lines 12, 13, 15, 16, and 17 are more straightforward. They basically correspond to other lines inside of main. So here is 12. We see I on 13, 1 on 15 here in the cout, 16 here in the argument, and here in the expression. Devars is basically telling us which variable's value may have been impacted by I. So here we see this expression, and ABC's value was essentially had I's value had some effect on ABC's because it was added to ABC in this assignment expression. I was not a pointer to anything, so its list here is empty. cfunc basically tells us which functions I was called on, which function it was an argument to, and then tells us which position it was in the argument. So here we see that it was, for foo it was in position 2, for fun it was in position 1, and we see again here foo was position 2 and fun was position 1. Quickly we see a pointers example down here with y. So if we look, y was a pointer to I because I was passed to it, and so here we record under y that it was a pointer for I. So let's see if our example is finished, and it is. So let's take a look at this really fast. p.txt. Let that load up. Alright, so here is the full slice for peer review. It's pretty big. If you look on the right hand side, you can see this big file. There's a lot there, so of course we're not going through it, but it ran in 145 seconds, 3 million lines of code in 145 seconds. That's pretty good. And that ends our demonstration. I hope you found it interesting, and happy slicing.